For many years, astronomers have closely monitored one of the brightest and most enigmatic stars in our night sky, Betelgeuse. This colossal red supergiant teeters on the brink of destruction. Experts have long warned that an explosive end was imminent, though they could never determine the exact moment it would occur. Now, in a groundbreaking development, the James Webb Space Telescope has captured what was once thought impossible: the precise instant when Betelgeuse began to explode. This event is far more than a routine astronomical observation. It is a rare, historic spectacle, marking the closest supernova ever witnessed by humanity. Located in the shoulder of the Orion constellation, Betelgeuse is no ordinary star. It is a red supergiant with a diameter more than 700 times that of our Sun and roughly 20 times its mass. Astronomers have long recognized the star's instability, as it frequently expands, dims, and erupts. When Betelgeuse suddenly dimmed in 2019, it sparked worldwide speculation that its long-awaited collapse might be imminent. Now, with Webb's unprecedented precision, the mystery has deepened. For the first time, we are witnessing real-time signs of a star in its final throes: enormous energy bursts, erratic surface convection, and magnetic fields spiraling into chaos. Betelgeuse isn't simply dying, it is transforming before our very eyes. The James Webb Space Telescope has been trained on Betelgeuse for months, utilizing its infrared capabilities to peer through layers of the star previously hidden from other telescopes. The data returned is extraordinary. Scientists can now observe massive convective bubbles, some as large as Jupiter, erupting on the star's surface. They can trace jets of searing gas rushing into space at astonishing speeds. Embedded in the star's spectral light is evidence of a shock wave rippling through its outer shell. For the first time in history, astronomers are directly observing the physics of a star dismantling itself. This is not a simulation. It is the live dissection of a supernova occurring just 642 light-years from Earth. Unlike supernovae that occur in distant galaxies, Betelgeuse's relative proximity means its eventual explosion will not only be easily visible, but could be brighter than the full moon, so luminous it might even be seen during the day. Beyond this dazzling spectacle lies an even more significant opportunity: a rare, up-close chance to witness the death of a star. This event allows astronomers to observe the collapse of a stellar core, the formation of critical elements such as carbon and oxygen, and the immense shock wave that reshapes everything in its path. What the Webb Space Telescope has captured goes far beyond the dramatic demise of a star. It reveals the very process by which the universe is enriched with the building blocks of planets and life itself. We are, quite literally, witnessing our cosmic ancestry in real time. The explosion of Betelgeuse is not merely an astronomical event, it represents a vital chapter in the grand story of how galaxies evolve, planetary systems emerge, and the cycle of life perpetuates across the cosmos. Thanks to Webb's unparalleled capabilities, scientists can now study a star's dying moments in extraordinary detail. This insight may one day allow us to predict future supernovae by identifying early warning signs in similar stars. This is more than scientific progress. It is a profound moment of discovery, a glimpse into the depths of cosmic time suddenly illuminated. Betelgeuse's detonation is not an isolated event. It sends out waves of energy across the cosmos, disrupting the interstellar medium for light-years around. Webb has already observed the first tremors, high-energy particles racing outward, energizing distant gas clouds and reshaping the dusty envelope that once surrounded the star. But the data hints at something even more profound: a detectable shift in gravity. Despite being 642 light-years away, the collapse of Betelgeuse's core may have generated gravitational waves, subtle ripples in space-time that scientists have only recently begun to detect. If confirmed, this would mark the first time a supernova observed visually is directly linked with gravitational wave data, potentially transforming our understanding of how light, matter, and space-time interact on the most fundamental level. Betelgeuse collapses. A profound question arises. What remains after its death? Will it become a neutron star, a black hole, or something entirely different? Data from Webb suggests the collapse might not be uniform. Scientists have detected magnetic disruptions, plasma voids, and possibly asymmetric fallback, where some matter fails to escape and instead falls back inward. Some researchers even propose the existence of a transitional object, a theoretical entity between a neutron star and a black hole that has never been observed before. If Webb has indeed recorded this phenomenon, it could be the first solid evidence of a new class of cosmic body. Given Betelgeuse's relative proximity, many wonder if Earth is in danger. The short answer is no. It is not close enough to pose any harm. However, the explosion will release intense waves of particles, gamma radiation, and electromagnetic bursts. These forces could disrupt cosmic dust clouds, influence neighboring star systems, and alter how light reaches us from distant regions. For now, Webb is carefully tracking the radiation's speed and spread. While we remain safe, this event may reshape how we observe the universe by altering our local cosmic environment. Betelgeuse is immense, ancient, and awe-inspiring. Yet it is dying. A solemn reminder that even stars, those seemingly eternal beacons in our sky, have their limits. What Webb has revealed is not just an end, but a reflection of life itself. Everything that lives must eventually cease, but in that ending lies creation. New elements will be forged, new stars will be born, and new planets may arise from Betelgeuse's remains. This is not mere destruction, it is cosmic renewal, and we are fortunate enough to witness it. Among Webb's massive trove of data, scientists uncovered something astonishing: rare variations in the elemental makeup of ejected material, alongside familiar elements like carbon, oxygen, and iron. The explosion released exotic materials such as technetium and yttrium, elements formed only in extreme stellar conditions. This discovery matters deeply, as analyzing these elemental ratios allows scientists to trace the full life cycle of matter across our galaxy, from dying stars to the cosmic dust that forms worlds, and ultimately to the atoms within our own bodies. Webb isn't just capturing an explosion, it is deciphering the chemistry that makes life possible. In its final moments, Betelgeuse is telling a story that predates Earth itself. Betelgeuse will not return. The brilliant star that once marked Orion's shoulder will be replaced by a growing cloud of incandescent gas and glowing remnants. But this is not merely an end. It is a profound legacy, a gift of knowledge about elemental birth and cosmic awareness. It serves as a poignant reminder that even our own sun is destined to fade, and that every shining point in the night sky is writing its final chapter. Yet from these celestial endings, new stories begin. Without the explosive death of stars, there would be no worlds, no seas, no life as we know it. Now, through the eyes of the James Webb Space Telescope, we are witnesses to this eternal cycle, where stellar death fuels creation. In the stillness of the cosmos, 642 light-years away, a star has reached its end. Not in silence, but with a brilliant resonance that traveled across time to reach our eyes. Thanks to Webb, we haven't just observed this moment, we have understood it. We have traced the signals, the collapse, the eruption, not as myth, but as tangible truth. Betelgeuse's final outburst was not in vain. It has answered ancient questions predating humanity itself. Where do the elements come from? How do stars meet their end? What fate awaits our own sun? Through its dimming brilliance, Webb has revealed more than a supernova. It has unveiled the story of our cosmic origins and offered a glimpse of what lies ahead.